All right, so I promised you yesterday, if you recall, that at the beginning of class today we would do the math practice, remember? Okay, and then we would turn you loose to do those 10 questions. I'm not going to do that because the previous classes today didn't have internet. We're going to pretend we don't either, okay? To keep the classes aligned. So first off, let me see if I can find another marker that works well. Not that one. Swish. Let's try this one. Nope.
It still works.
Swish. I'll just use the can you see the orange okay? Awesome. So, heading of your notes. Hooke's Law. For the heading up top, I'm going to put it down here, but that's just general space. Hooke's Law. That's what we're dealing with when we're talking about spring and spring's constant and all that good stuff. Springs and spring constant. There we go. And in the far left corner of the board over there, super clear and easy to read, so I'll read it to you, okay? Because I know it's crammed in there, is the formula for Hooke's Law. So it goes like this. Force, F for force, right, is equal to negative kx. So I'll put it here just temporarily. Force is equal to negative kx. F, force in newtons. The negative k is the spring constant of whatever spring you're dealing with. And the reason it's negative is because it's always going to be acting in the opposite direction of an applied force. Remember Newton's third law, for every action force there's an equal opposite reaction force. The spring, the restoring force that the spring provides is the reaction force, so it's negative. And then x is how far that spring is either stretched or compressed. So that's displacement. Guys, don't blame me. Blame Hooke for using an x for displacement instead of a letter d like we have in some of our other formulas. Does that make sense? All right, so I'll leave this right here. Where we're going to start with this question, though, take out from the word problem what you're given and put it in the formula. Here we go. A spring with a spring constant k of 100 Newton meters, okay, of course that would be negative 100, right, is stretched 0.2 meters. So your displacement's 0.2 meters. The spring constant is negative 100 Newton per meters. Newtons per meter, there we go. And the question is asking, what is the restoring force produced by or exerted by the spring? So what do we have? What are we given? We're given K and displacement. So we're given, we can use the formula exactly as written, right? And it keeps it super simple. So just replace or drop in what you're given. So negative 100 Newton meters times x, which is 0.2 meters. Somebody drop that in a calculator. Hold. Don't blurt it out. Let everybody get a chance. If you need a calculator, go grab one.
Is that
N / like division M. Newton meters. Newton meters is the unit for a spring constant. Capital N for Newton and lowercase m for meter. Newton meters. Not Newton. Oh my gosh. Not Newton meters. That's something different. That'd be multiplying. This is Newtons per meter. You almost had me again. No stabbing other students or hitting with calculators or whatever that was.
I'm sorry.
Okay. All right. Shh. So everybody, all at once, tell me the answer. 20?
200.
200?
Negative 20.
Negative 20?
I didn't
We're getting closer.
Negative 5.
No, I mean the number's right now. Negative 20. We're missing the unit. Newtons, because we're looking for force. Good. All right, check it out.
Oh, so negative 20 newtons.
Yes. Shh, listen. You could have done that by plugging it in a calculator, but listen to this one, okay? I want you to think about math different ways whenever you get a chance. 0.2, you could also verbalize that as 2/10. And then you say, well, 2/10 of what? 2/10 of 100. 10 twice in 100. 20, right? And then you just make sure you don't forget the negative sign. So, negative 20 newtons. All right, cool. We're done with that question. Let's move on to this one right here. I'll read out loud. You read along with me. Pull out what you're given. Plug it in the formula. It says a force of 50 newtons stretches a spring. The spring constant is 200 newtons per meter. How far is it stretched? So, I guess first thing you could say is, well, what are we looking for? What are we trying to answer? What are we trying to get? Displacement. How far? So why don't we, you don't have to, you can use the formula as is written, but couldn't we rearrange the formula?
Yeah.
Right? So that we're actually finding x from the start. Wouldn't it be x equals something, right? If you're trying to find x, we've isolated x, how do we get negative k away from it?
Division.
We divide it out. So we're going to divide by a negative k here and over here. So x equals force divided by negative k. Everybody follow?
Yes,
Now,
sir.
take what you're given and plug it into that formula. Well, if you've already got the answer, hold it for a second. Let everybody catch up.
Oh, wait. I only got it right.
So you're just going to plug in. So we're going to put another equal sign here. What's force? 50 newtons. What is negative K?
200.
It'd be negative 200 newtons per meter. Okay?
Negative 0.25.
We put it in the calculator and we get
Negative 0.25.
x equals negative 0.25. Negative 0.25 what?
Newtons per meter.
No, meters.
Meters, because we're looking for distance, how far, displacement, right? And hey, if you forgot that, look at the math. When we divide, don't the newtons go away? The newtons divide out, all you're left with is meters. Okay? All right, one more, and then we're going to move on to
So
the
it's 50 divided by negative 200.
yes. Hey guys, I'm glad you brought that up. I've, for years, probably since I started teaching this kind of math, one of the most common things I see is students putting division in backwards. No, it's very common. You're shaking your head. No, maybe not for you, but I have probably at least a quarter of my students every year at some point will flip these. So what I want you to ask yourself is, how do we read? Left to right and
Top to bottom.
top to bottom. So if we read left to right, top to bottom, that applies to math too. So if you see a fraction, that's a division problem, right? And we do it top to bottom. So 50 divided by that line in a fraction is, it says divide, right? So 50 divided by negative 200. Good, thank you. All right, so that's your answer if we also make sure we put the meter there. All right, last one. Over here. A spring, same formula. Okay, you might need to modify the formula. I'll give you time. A spring is compressed this time. It's not stretched, it's compressed. 0.05 meters by a 20 Newton force. What is the spring constant? Go ahead.
You said 0.5?
0.05. So it'd be 0.05 meters.
That'd be an F.
No. I'll read it again. A spring is compressed 0.05 meters. There you go. By a 20 Newton force. So you're given the force and you're given the displacement find the spring constant. So you're going to be isolating which variable?
20.
The negative k. You got it? Don't blurt it out. You got it though? Okay, cool.
Hold on, I have a question. Would the x, would that also be a negative?
No.
Even though there's a variable in front of it?
No, so negative k, the negative will only go to the spring constant. All right, everybody all at once, tell me the answer. 3, 2, 1.
400.
Negative 400.
400?
That's what they
Negative 400?
Yes.
What?
Meters.
Per meter. I don't see no negative.
Newtons per meter. Because we're looking at the constant, the spring constant.
I
Good.
don't know why I haven't answered.
All right.
Wait, so it's positive, right?
You want me to work it? How many of y'all didn't quite get it and need me to work it? Raise your hand if you want me to work it. Okay. Or you got it, but you're not sure how.
I don't know how it's
Okay? Shh. So, the first thing we did is isolate our variable, negative k. Now, to get it by itself, we would have had to divide the x away from it. So, force divided by the x. Okay? The displacement. And then we have this. This is 20 newtons, and we have the displacement 0.05 meters. Right? So we just divide down, we end up with 400, correct? And it'd be in newtons per meter. Newtons per meter. And then we just take that negative
So
sign.
it's division, it's not times.
It's division. Yep.
So then it's negative 1.
Yep.
I just found the negative.
Okay. Because it was over here. Yeah. All right. I'll give you time. Hey. I'll give you time at the beginning of class tomorrow, because we're pretending we don't have internet right now. I'll give you time at the beginning of class tomorrow to work those 10 questions. All right? What I want to do now is shift gears